given that y is equal to the power a x plus 6 and 4 plus 2y is equal to 16x at 2 parallel lines, find the value of a. So we have been given that y is equal to the power a x plus 6 is parallel to 4 plus 2y is equal to 16x. So what is the rule of parallel lines? Okay, the thing is, if you are told that this equation is this equation is parallel to this equation, that means the two gradients in those two equations must be the same, and are the same. I should say that are the same. If you are told that this equation of a line is equal to this equation of a line, you have to know that the gradient in those two equations are the same. So gradient is found where there is x. So you have to know that gradient is found where there is x, or it is the coefficient of x. Like in this case, this is our gradient. Okay, 2 to the power a is our gradient. But in this case, we cannot say that this 16 is what? Gradient of this equation of the line. First of all, we have to make y subject of the formula, and after that we will know our gradient. What I mean here, okay, this one is okay, y is already subject to the formula, but in this case y is not subject to the formula. So let's make y subject of the formula. Oh, I don't know the spelling, doesn't matter. Formula. So in equation, so the equation is 4 plus 2y is equal to 16x. So 4 plus 2y is equal to 16x. Okay, and then this 4 we go to that side, it will be 2y is equal to 16x minus 4. Since it is positive, after going to this side it will be minus. We have to divide with 2 here, divide with 2 here, divide with 2 here, so that we make y subject of the formula. And 2 into 16 it is 8, and 2 into 4 it is 2. That means y is equal to 8x minus 2. So since the equations are parallel, that means the gradient are the same. I already said that. So in this case, this equation, our gradient is 8, and here our gradient is 2 to the power a. So here 2 to the power a is equal to 8. Okay, so gradients are the same in equations of parallel lines. That's why 2 to the power a is equal to 8. 2 to the power a, the gradient of this equation, and the 8, the gradient of this equation. I think you understand. So in this case, you can use the different what I can say different ways for you to find the value of a. So the simplest one, the one that you can see first, you can understand it faster, just make this 8 a base 2 with a certain power so that you get 8. Okay, so that you use that row of index, same bases, equal powers. So it will be 2 to the power a is equal to 2 to the power 3. Since in indices, if you have same bases, that means the powers are also the same. So a is equal to 3. Reason, same bases equal powers, or same bases, same powers. I think it's just the same, like that. Sure. So that is how you can solve that one. A is equal to 3. But maybe some of you may want to know the other way. Okay, so let me take this part. Okay, at this stage, 2 to the power a is equal to 8. You can use the rows of indices. Okay, the rows of indices, it says that log of this 8, okay, base 2, it is equal to a, like that. So it can be in that form. It is also the same. So that means the value of a is log of what? Of 8. So next, this one, it can be 2 to the power 3 is equal to a. Okay, so this power can go to this side, and it can be 3 log 2 base 2 is equal to a. Since here you have log 2 of 2, that means the log 2 of 2 is 1 is equal to a. 3 multiplied by 1, it is 3. So the value of a is 3. Okay, so from this stage here, you can use this formula, some bases equal powers, and you find a is equal to 3. Else, you can use the rows of indices, like this one. 2 to the power a is equal to 8. Then you use rows of indices, log 8 base 2 is equal to a. Okay, then you simplify this one, it will be 2 to the power 3. Since 2 to the power 3 is 8. Okay, and this 3 then goes to this side, and then it will be 3 log 2 base 2 is equal to a. And since this number is equal to the base, you remove this one and you put 1. 3 multiplied by 1 is 3. So the value of a is 3. Simple.